All right, so I think this is recording. Let's solve this quadratic inequality. If we look at the expression that we have it compared against 0. If we look at the terms, there's no greatest common factor. So we want to factor this trinomial. Our middle term is 2x. Our first times our last is negative 8x squared. Two values that multiply together to give me the top expression, but add together to give me the bottom, are 4x and negative 2x. With a leading coefficient of 1, I do not have to make a table below because I know I'm going to use the 4 and the negative 2 directly. So I have x plus 4 and x minus 2, and that is strictly greater than 0. So I'm going to use these values of negative 4 and positive 2, and they're often referred to as critical points. I'm going to leave both of those out of my solution set, both of those hollow, because this original inequality is a strict inequality. It doesn't say greater than or equal to, it says strictly greater than. So this divides my number line into 3 regions that I'm going to label A, B, and C. I'm going to make a table to kind of be organized. Later on, I suppose, when you get good at doing this, and after you've done it a few times, you can probably do the rest of this in your head. But until then, I suggest being organized and proceed by a table. So one column is, I'm just going to label it test point. The next column, I'm going to use my inequality, but I'm going to go ahead and use my factored form. You could use the original inequality if you want, but it's easier for me to do arithmetic on it in this factored form. This last column, I'm going to label it my truth column. So from region A, I'm going to pick a test point. A number that is smaller than negative 4, well, negative 5. I'm going to pick integer values. I'm not going to pick crazy fractions because I'm going to have to do arithmetic on this, and I want it to be as easy as possible. So negative 5 plus 4 is a negative 1. Negative 5 minus 2 is a negative 7. And negative times negative is positive. Positive numbers are greater than 0. That's a true statement. And I'm going to include all of the points in my solution set. So I'm going to shade in all of the points. I'm going to shade in all of A. Now, from region B, I'm going to pick a test point. And since it's going from negative to positive values, I'm going to pick 0, because that's an easy point to do arithmetic on. 0 plus 4 is 4. 0 minus 2 is negative 2. But negative 8 is not greater than 0. Negative numbers are smaller than 0. So this is a false statement. So I am not going to include any points from region B in my solution set. All right, so what about in point C? I'm going to pick a number greater than 2, something like 3. And 3 plus 4 is 7. And 3 minus 2 is 1. 7 times 1 is 7, and 7 is greater than 0. That's a true statement. So all of those points are going to be in my solution set. So I have a picture now of my solution set. I want to write that picture, describe it using interval notation. No, using an inequality. Well, we will be using interval notation in the next skill packet, and we use interval notation throughout the year after that. So I'm so used to saying interval notation, but really, since we haven't gotten to that yet, we are using inequalities. So x is strictly less than negative 4 in this interval, or, so we need an or statement. X is strictly greater than 2, and that's my final answer. So I hope this helps. Let me know if you don't be afraid to ask any questions, and I will talk to you later. Bye.